HS 3.1 Functions of the liver and biliary system. So first let's have a look at liver anatomy and blood supply. So the liver has two lobes. It's got the right lobe, which is larger. It's got the left lobe, which is smaller. Above the liver you have the diaphragm. In terms of blood supply, the liver is supplied from two things. Supplied from the portal vein, which is larger here, and the hepatic artery. Hepatic artery is 25% and it's fresh blood from the heart, whereas the portal vein is 75%, so most of it, and it's blood from the intestines. The blood then supplies the liver and leaves through the hepatic vein into the inferior vena cava, into the right atrium of the heart. And the hepatic vein, inferior vena cava, it makes like an indentation in the back of the right lobe of the liver. Behind the liver you have the gallbladder. At the top you can see the fundus of the gallbladder. At the bottom is visible, and it has various ducts leading to the common bile duct, which is bile into the intestines to form micelles with the fat to allow fat absorption. So let's have a look at the liver structure in a bit more detail. Well, the liver has a central vein which blood passes towards from the hepatic artery, which, as I said, is smaller, the branch of the hepatic artery, and a branch of the portal vein. The blood goes through the sinusoids into the central vein. Now, the hepatocytes produce bile, and this goes the opposite direction. So this is all going this way to the central vein, whereas the bile goes the opposite direction, through the bile canaliculus into the bile duct. Now, the sinusoids are lined with hepatocytes, which are the liver cells. The sinusoids have within them the Kupffer cells, which are the macrophages that destroy red blood cells. And between the hepatocytes into the sinusoids you have these septal branches. So the hepatic artery branch, let's have a look at the lumen of the artery. Well, and the layers of the artery. The vessels are lined with squamous epithelium, and the purpose of this is protection against blood cells and viruses, regulation of leukocytes, coagulation and regulation of coagulation, and also absorption of solutes. So that's the vessel's squamous epithelium. However, the bile duct is lined by polarized cuboidal epithelial cells. And these are for transport and secretion. So let's have a closer look at the liver anatomy. As you can see here, this is the lumen. And as I mentioned, the lumen contains Kupffer cells, which look like this. The lumen is lined by these hepatocytes, as you saw in the drawing earlier. However, there's a gap between the lumen and the hepatocytes, and this gap is called the space of Dis. And the purpose of this space of Dis is to allow absorption into the hepatocytes. The hepatocytes, between them, have bile canaliculi. The space of Dis is created by the hepatocytes and these endothelial cells, which are fenestrated with holes in them, gaps between them. And the space of Dis also contains cells called stellate cells. So they look like stars. And stellate cells, the ones in the space of Dis, they're called ito or ito cells. The purpose of ito cells is fat storage. And they also produce extracellular matrix, which becomes fibroblastic during disease. And the way I remember ito cells being fat storage is I for fat, because I cells in the duodenum respond to fat in the duodenal lumen. There's also dendritic cells. So now looking at the cells, the hepatocytes themselves, they're very metabolically, they're irregular polyhedral cells and they're metabolically active. So this gives you a clue as to what they contain. Well, they contain rough endoplasmic reticulum, Golgi, mitochondria as shown here, and smooth endoplasmic reticulum. The smooth endoplasmic reticulum is for the synthesis of bile acids from cholesterol. They're also polarized in that they have different domains. There's essentially 3 different domains or sides. There's the sinusoidal domain, which leads into the sinusoid, which is for the blood flow. Either side, blood flow from the hepatic artery to the central vein, hepatic and portal vein to the central vein. Sorry. You've got the lateral domains, which is between so this cell will be repeated alongside. So that's the lateral domain. And they're held together by tight junctions called integrins. Integrins are proteins that hold them together. This is the lateral domain. They're held by tight junctions and desmosomes, sorry. And it also has a canalicular domain. And this is the bile canaliculi for the bile acids to pass into bile canaliculi to pass in the opposite direction, right? The basolateral domain, it also has microvilli for absorption and pits for exo and endocytosis into the sinusoid. Remember the space of disc between the hepatocytes and the endothelial fenestrated cells.